For this video, I will going to discuss about three configuration, namely Pappus, Desargues, and Hesse configuration. Pappus configuration is named after Pappus Alexandria. Pappus Alexandria is one of the last great Greek mathematician of antiquity. He proposed the Pappus hexagon theorem in projective geometry. So Pappus configuration, this figure is come from the idea of a Pappus hexagon theorem. So this is closely related to a Pappus hexagon theorem. So now let us discuss those 4 points of this figure. It says here, Pappus configuration is a configuration of 9 lines and 9 points that occurs in Pappus theorem, with 3 points per line and 3 lines to each points. Meaning, on this figure, on the Pappus configuration, there are 9 lines, 9 points. 9 lines, line 1, 2, 3, 4, 5, 6, 7, 8, and 9. And there are 9 points. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And also, per line, there are 3 points. Meaning, per line, first line, there are 3 points. 1, 2, 3. Per line, 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 1, 2, 3 points. And so on and so forth. And also, vice versa, there are 9 lines to each points. Point A, point small a, 1, 2, 3. Point small b, 1, 2, 3 lines. Point small c, 1, 2, 3 lines. And so on and so forth. And second point, Pappus line does not pass through the point of intersection of large ABC and small ABC. This configuration is called self-dual. So this Pappus configuration is called self-dual because there is no line that pass through the point A, B, and C, and also small a, B, C points. And since those opposite sides of line large A, small b, small a, large B line are opposite, and also large B and small c line and small b, large C line are opposite sides, and also large A, small c, and small a, large C line are opposite sides. Therefore, this is called a self-dual. Next one, the incidence graph of a Pappus configuration is known as the Pappus graph. So this configuration is also an incidence graph. Therefore, it is also called a Pappus graph. And lastly, Pappus theorem states that every two triples of collinear points, large ABC and small ABC, none of which lie on the intersection of two lines, can be completed to form a Pappus configuration. Hence, by adding the 6 lines, line large AB, small a, large B, large A, small c, small a, large C, large B, small c, small b, large c, then they make an intersection points, namely point X, Y, and Z, where X is equivalent to line large AB and small a, large B, point Y is equivalent to large A, small c, and small a, large C, and point Z is equivalent to line large B, small c, and small b, large C. Then, these points of intersection of the opposite sides of hexagon, large A, small b, large C, small a, large B, small c. So, state on this figure that if we add 6 lines, namely line large A, small b, small a, large B line, small a, large C line, small large A, small C line, large B, small C line, large C, small B line, then there exists a point, namely point X, Y, and Z of this line, of this opposite line, line large A, small b, small a, large B line. And also this one, there exists an intersection point Y of these opposite sides, and also this one. And now The second configuration that I will going to discuss is about Desargues configuration. Desargues configuration named after Gerard Desargues. Gerard Desargues is a French mathematician and he is considered a founder of projective geometry. He proposed the Desargues theorem. So this configuration came from the theorem of a Desargues. It is come from the idea of Desargues theorem. It is closely related to it. So Desargues configuration is a configuration of 10 points and 10 lines with 3 points per line and 3 lines per point. 10 points 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And also 10 lines 1, 2, 3, 4, 5, 6, 7, 8, 9, and also 10. And per line, there are 3 points. Meaning per line, first line 3 points, 1, 2, 3. Per line 3 points, and vice versa. There are 3 lines per points. Per point, 3 lines, 1, 2, 3. Per points, 1, 2, 3. And this is the Desargues configuration. Next one is Desargues configuration of a two-dimensional says that two triangles ABC and small ABC are said to be perspective centrally if the lines large A, large B, small b, and large C, small c meet in a common point called central perspective. Then they are perspective actually if intersection point of corresponding triangle sides x is equivalent to large A, large B intersection of small b, small a, small b, and point y is equivalent to line large A, large C intersection of small a, small c, and point z is equivalent to large B, large C intersection of b, small c. All lie on a common line called the axis of perspectivity. Meaning they are perspective centrally if those lines are met in a common point. Meaning line large A and small a meet in a point O. Large B and small b meet in a point O. Large C and small c meet in a common point which is called perspective centrally. Then it is perspective actually since sides large A, B and sides small a, b lie on a line P, and large B and large C side and small c, small b sides lie on a line P, and also large A and large C side and also small a, small c side lie on a line P. So this is called perspective actually. Next is Desargues configuration is closely related to Desargues theorem. Like what I said earlier, that this figure is closely related to a theorem of Desargues. Since Desargues theorem says if two triangles are in perspective actually, if and only if they are perspective centrally. Denote that three vertices of triangle small a, b, and c and those of other by large A, B, and C actually perspective means that line small a, b, and large A, B meet in a point. Lines small a, c, and large AC meet in a second point, and line BC and large BC meet in a third point. And these 3 points are lying on a common line called axis of perspectivity. For this thought is also this thought. It is the same. So proceed to the last since points corresponds to lines and collinearity of points corresponds to a concurrency of lines, and since axially perspective is translated to central perspectivity and vice versa, the Desargues configuration is self-dual, meaning this Desargues configuration is perspective centrally and perspective axially, meaning they are meet in a common point, which is point O, and they meet in a common line, which is line P. Therefore, this is called self-dual. This is the last configuration that I will going to discuss. Hesse configuration. Hesse configuration is introduced by Colin Maclaurin. He is a Scottish mathematician and known for being a child prodigy. He also holds the record of a youngest professor, and introduced also the Taylor series and Maclaurin series of a infinite series. Then now let us discuss those points of Hesse configuration. Hesse configuration is a configuration 9 points and 9 lines and 12 lines with 3 points per line and 4 lines to each point. Meaning 9 points, 1, 2, 3, 4, 5, 6, 7, 8, 9. 12 lines, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. With 3 points per line and 4 lines through each points. Per line, 3 points. Line 1, 2, 3, line 1, 2, 3, and so on and so forth. And through each point, there are 4 lines. Point 1, 2, 3, 4. 1, 2, 3, 4 lines. 1, 2, 3, 4, and so on and so forth. Next, note these 9 points and 12 lines of Hesse configuration is not realized in Euclidean plane. It only realized in complex projective plane. Next, 4 of each line is broken diagonal of 3 by 3 array, meaning these are the 4 broken line of a 3 by 3 array. Next one, the Hesse configuration has same incidence relation as the lines and points of the affine plane over the field of 3 elements, meaning this configuration satisfies the affine plane, the axiom of the affine plane. Affine plane, axiom 1, 2 distinct points lies on a unique line, meaning this point and this point having a unique line. From this point having a unique line. Next axiom, axiom 2, each line has at least 2 points. Each line has at least 2 points. This line having 2 points, at least 2 points. This line having 2 points. This line having 2 points. And axiom 3, given any line and any points, not on that line there is a unique line which contains the points and does not meet the given line. Given a line and a points, a line and a points, not on that line there's a unique line. There's exists unique line. Given a line and a point, there exists a line and a point, and does not meet a given line. And axiom 4, given a point and a line, there's a unique line contains the point and is parallel to the line. Meaning given a point and a line, there is unique line contains point and is parallel to the line. There is unique line contains point that is parallel to the line. From this line, this point, given 2 points having 1 line is parallel to this And lastly, action 5, there exists 3 non-collinear points and does not on the single line. Meaning there exists 3 non-collinear points, 1, 2, 3, and does not on a single line. Not only a single line, not on a single line. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, going to this, 2, 3. Next is the points of a Hesse configuration may be identified with order pairs of number modulo 3, and the lines of configuration may correspondingly be identified with triple of points x, y satisfying linear equation ax plus by is equal to c mod 3. Meaning, a points can be identified from this Hesse configuration by an order pairs. Let's say we have point A, B, and C, D, E, F, G, H, I. Meaning, a point can be identified by an order pair. Let's say order pair of A, B, B, C, C, D, C, F, rather, F, I, D, G, H, I, and so on. And a line can be identified also by a 3 point. A line can be identified by 3 points. 1, 2, 3 points. 1, 2, 3 points. 1, 2, 3 points. Identified the line by 3 points. 1, 2, 3. Namely, point A, B, and C. Point A, D, and G. And so on. And lastly, the points of a configuration may be identified by a square of a tic-tac-toe board, and the lines may be identified with the lines and the broken diagonal of a board. Meaning, this is an alternative solution to find the lines and the points of a Hesse configuration using a square of a tic-tac-toe board. What is a tic-tac-toe board? A tic-tac-toe board is a board wherein having a 3 by 3 square array. This is an example of a tic-tac-toe board, which is also our Hesse configuration. 3 by 3 square array, and it is an easy way to find the points and the lines of a Hesse configuration. And that's all. Thank you for watching.